Okay, so I just want to give a brief introduction to classification systems. Sounds like it might be totally unrelated to what we've been doing in class, but it's really not. Scientists and engineers use classification systems all the time. You might hear a biologist talk about a dichotomous key. A dichotomous key is something that a biologist would use to figure out what kind of snake you found in your backyard. How do you know if the snake is poisonous?
You let it bite you.
No? No, before that, before you let it bite you, you want to know if it's going to be poisonous or not. So how do you know if it's poisonous or not? If it's got a certain shaped head, there's a pretty good chance that it is poisonous. Right? Yeah. So biologists are crazy into these dichotomous keys. There's classification systems. Maybe when you were in elementary school, you did a little project where you had to identify leaves, right? So you knew what kind of tree it was. So all kinds of classification systems. They're very prominent in biology. I would like for you guys to come up with your own classification system for type 1, type 2, type 3, type 4. So as you know, Anna says, she says, I get really confused. How do I know which type it is? So you've got to be able to answer some questions. When I talk about a class, here's a classification system for figuring out how to name an object, a multi-sided object. Right? So like some quizzes that you might have seen in Teen Magazine when you're trying to decide who to take to the prom or what shoes to buy or that kind of thing, there's a start place, and that's usually shown as an oval. And then you come to some questions, and based on your answers to those questions, you're going to take a different path through the quiz. So for example, I want everybody to, let's think, we'll pick one. Angelina, give me think of a multi-sided object. It has to, give me one that's one of these here. Because these are the results. This is how we're going to get. So we're just going to try it. So tell me a multi-sided object. Pick one.
A square.
A square, okay? So we start at first question. Does the object that Angelina is thinking of, does it have less than 5 sides, yes or no?
Yes.
Yes, it does, all right? So we take the route this way. Does the object that Angelina is that she's thinking of, does it have 3 sides?
No.
No, okay. So we're going to go over here. Are the sides equal in length?
Yes.
Yes, they are. So we follow the yes side, and we call the object she's thinking of a square. So this is how you would get yourself through a classification system. So what I want to do is take you through how you might put together a classification system so that you know what type of compound we're talking about, and I might let you use that classification system on the test to help you. Okay? So I'm going to give you an abbreviated version of what I call the Qft Protocol, and Qft Protocol is question formation technique, and it is a strategy that I use to help students ask questions for scientific inquiry. Meaning if we're going to go and do a lab, and I just don't want to give them a cookbook, say cookbook lab, say do this, do that, and the other thing, and then you're going to get this answer, and then why did you get it or why did you not get it? I don't like to do those kinds of labs. I would rather say, hey, we're going to the lab today, what would you like to do? Well, I can't just turn students crazy in the lab, just go around doing random things. They really have to have a focus on what they're doing. So the Qft Protocol is one of the first steps that I use to get students to think about scientific inquiry. What might they do in the lab? It's also a good step for us today to help us start thinking about what a classification key might look like for naming the types of compounds. So the Qft Protocol starts out with a prompt that says, what questions would you have to have answered in order to determine what type a compound it is? So what you're going to do, what I would like for you to do in your group, there's one piece of notebook paper, there's one person that has some pretty decent handwriting. What I would like for you to do is give the person writing a question to write down. And they're going to write down the question. Now here's some very important rules about the Qft Protocol. You're just writing down questions. You are not answering questions. You are not judging questions. And you write down those questions exactly how they were stated. The reason is that someone might write down a question and you might think they asked one question, but they really ask another. And so you don't want to stop and say, oh, that's dumb. No, we're not going to judge it. You're not going to answer the question because it might not be the question that was really intended in the first place. So what I want you to write down is I want you to write down at least 5 questions that if you had the answers to them, then you would know what type of a compound it was. Okay? Okay, what I'd like to do is come up with a class list of questions. So let's just go around the room. I'm going to start over with Sam's group. What is one question that you would have to know in order to determine what type of compound it is?
Does the compound only have 2 nonmetals?
So I'm going to do a little interpreting of your questions. Is it binary? Because I heard you say 2. But you said something else. What else did you say?
That it's 2 nonmetals.
Okay, is it binary? Is it 2 nonmetals? I'm going to write both those down. I like that. Kaylee Balmas, what did your group come up with for some questions?
What's the oxidation number?
Okay.
What elements are in the compound?
What did you say?
The second one is what elements are actually in the compound.
Okay. Okay. What are the oxidation numbers? Does that help you figure out what type it is, though? You have to use oxidation numbers with type 1s. Do you have to use oxidation numbers with type 2s? Yes. Do you have to use oxidation numbers with type 4s? Yes. Do you have to use oxidation numbers with type 3s? No, because those are nonmetal covalently bonded. They don't have oxidation numbers. But if you knew, does it have oxidation numbers, maybe that would tell you whether it's a type. If it doesn't have oxidation numbers, it would tell you it's a type 4, wouldn't it? Or type 3, wouldn't it? Right? Does it have oxidation numbers? Okay. I mean, it'd be ionic then, right? Oh. Okay. Well, those are my questions, not yours. So, Dominic, what'd you come up with for a question?
Can a ionic compound with a cation have more than one element?
I think what I heard you say is, does the cation have more than one oxidation number? If it does have more than one oxidation number, what type would it be? 2. Yeah. Does the cation, the cation, have more than one oxidation number? Hey, there's a couple other ways we could figure this out. You could say, is it special? And then, or you could say, is it on the list of special ions? Then you would know as a type 2. Okay? All right, Anthony, your group.
Does it have a metal cation from group 1, 2, or 13?
Okay. Is the metal cation from group 1, 2, or 13? If it is, what type is it? Kind of sounds like a type 1 to me. Kind of sounds like it might be a type 1 if it has a metal cation from groups 1, 2, or 13.
Wait, okay. Do you have like a specific way of how you can
That's what we're doing. So I'm stepping you through a procedure how you might come up with a classification key for determining the type. Remember at the beginning I showed you an example of classification key that told you whether it was a triangle, a square, or a polygon, an n-gon, right? So what your project is going to be is to come up with the classification key for determining what type it is. And then you can use that on the test to help you determine what type it is. If you know what type it is, do you know how to name it?
Yes.
Yeah. So that might be a pretty helpful thing to know, right? All right, one more table here. What did you guys come up with?
Is it combined with the non-metal anion?
Okay. Wait a minute. All of them have non-metal anions. As long as we're talking about ionic compounds. So this has come up a couple of times. Is it ionic or covalent? If it's covalently bonded, it's going to be a type 3. If it's ionic, then we got all these other types to deal with. Okay? There's a couple of more I don't think we have. Anybody have one that they don't see up here already? Yeah.
Is the oxidation number represented by Roman numerals?
Okay. Once we have the type, then there are rules for naming. Okay, so I'm going to draw a little boundary here. Use Roman numerals. Okay. What do you got, Kemez?
Is part of it on the polyatomic ion system?
Okay, so use polyatomic names. Okay, anybody else see something that we haven't got up here yet? If it's a type 3, how do we name it? With prefixes. Use prefixes. So if you know what type it is, and you can figure the type out by answering some of these questions here, then you know, then you have a strategy for naming them, right? So Roman numerals, this would be for a type 2, right? For polyatomics, that's a type 4. Prefixes would be for a type 3. And for type 1s, it's just the old ordinary way, right? You do something like add IDE. So you name the cation, then add IDE to the anion. Say the cation. And then add dash IDE to anion. Okay, so these are kind of the rules for naming after we figure out what type it is. Here's the hard part. Taking these questions, making diamonds out of them with yes-no paths in such a way where you start I'm going to draw a big black box. And then out the other side, you've got type 4, 3, 2, 1. Okay? Your job, what goes in this black box? You ever heard about the black box approach to problem solving? You say, I know what I'm going to start with. I know what I'm going to start with, and I know what I'm going to end with. How do I get from here to there? So you're going to have, let's just say, you're going to start with some compound, and I'm going to represent the cation or the first element or group of elements, in case it's polyatomic. I'm going to represent that as an A. And then I'm going to represent the anion, which is the element that comes next if it's binary, or the group of elements if it's polyatomic. I'm going to represent that as a B. And then there might be some subscripts, so AX and BY. This is just a generic formula for any compound that you might want to name. So if I give you, for example, if A happens to be Li and B happens to be F, okay, then you might ask yourself, is there a metal? Well, yes, lithium is a metal, and that'll take you down a different path inside the black box. Can you kind of see where I'm wanting to get you to go with this? All right. So here's some example questions that you might have inside the black box, and then you have to determine the route that you would take to get you to where you want to go. Once you figure out the type, then you have the rules for naming. And if you had that on a piece of paper during a test, it would make your life so much easier. And that's my job, to make your life, your learning life easier, right? All right. Okay.